this equilibrium unit is all about insoluble solids. So we reminded ourselves of this gorgeous big bird yellow precipitate that's created with lead-2 iodide. And I'm encouraging you, of course, to imagine the particulate diagrams. And so we are beginning with separate lead +2 and nitrate ions. What's really nice about that first image is they are respecting the ion ratio, because we're going to have one lead +2 for every one nitrate. And we would definitely anticipate that the nitrate molecule is larger than the lead +2 because of all those oxygens on there. And then we're reacting it with potassium iodide, completely dissociated. We'll have one potassium for every one iodide. Well, how do we know if a precipitate will form? How do we know if we have the concentration of lead ion in solution to find enough iodide to actually create the solid? That's what QSP, or most textbooks call it ion product. And so if this is what we're intending to make, all right, well, we can kind of back calculate, if you will. Oh, for heavens. I'm so sorry, my brain started to just think of the next thing. So this is going to be creating Pb plus 2 iodides. All right, and the question is, do we have sufficient concentration of these that will lead to the creation? And so in essence, we're kind of working backwards. We're not going to get these unless we have some of that. And so if we take a look at KSP, that of course is at equilibrium. And we know this is describing a saturated solution. And so if we know our KSP value, then what we can do is say, okay, initially I have a certain concentration of lead and a certain concentration of iodide. Do I have the concentration there to meet KSP? So we have QSP. Remember, QSP is just when we're questioning if we're at equilibrium or not. And so these are usually what we're looking at as initial amounts. And so what is the situation that we're given? What volume and concentration of our different ions do we have? And is it less than or greater than KSP? If QSP is greater than KSP, then the precipitate will form. We have plenty of ions that will find each other to create solid. But what if QSP is less than? Then no, just the probability, they're so low in concentration that they're not going to find each other to lead to the creation of solid. And so if QSP is less than, the precipitate will not form. Now, if QSP equals KSP, well then you're at equilibrium. That really won't be a circumstance for this unit. We're looking at, okay, are we gonna see a good amount of solid form or not? So let's dig in to this example. Now, often these QSP problems just require a little more work from us because we're often adding volumes of different concentrations. Okay, this problem is asking, will cerium iodate precipitate? Okay, so this is what is my solid reactant, and I am creating, if I'm saturated, 1 cerium plus 3 for every 3 iodates. All right, and the KSP, 1.9 times 10 to the minus 10th, will be equal to my cerium plus 3 and then my iodate cubed. All right, so the question is, am I getting this precipitate? So that should immediately direct us to find QSP. All right, so QSP, it will be the concentration, and I'm going to go ahead and call it initial of each of these. So from the given information, I need to find out what is the concentration of cerium and iodate by adding these. Okay, so I have 750 milliliters of, I'm going to take this out of scientific notation. It's up to you. 0.00400 molar. Now, I just need my cerium concentration. And for every one of these, it gives me one cerium. So that is my concentration of cerium plus 3. And I'm adding to 300 milliliters of 0.0200 molar. And I just want my iodate, and every one potassium iodate gives me one iodate. All right, now what I need to find out is, well, what is my concentration of each of these when I've combined them, and I'll now have that total volume. So it's up to you. In essence, we're diluting. And so if you want, we could apply the dilution equation. And so the question is, all right, given 0.00400 molar cerium, and it's a volume of 750 milliliters, what will that be in 1,050? Oop, I'm so sorry. That would be fine. We also could just do the dimensional analysis and say, so I'll do that for the iodate, 300 milliliters, and every 1,000 mils of iodate is 0.0200 mole of iodate. Well, what will that be in 1,050 milliliters? And then I'll have to get to liters. Yeah. So that'll cancel that, and then I'll have mole per liter. Okay, so each of these, my cerium is 2.86 rather, times 10 to the minus third. And then my iodate is 5.71 times 10 to the minus third. And then I will plug these in, being very careful of my exponents. And 5.71 times 10 to the minus third. And that's cubed. And whenever I do the math, I get 5.32 times 10 to the minus 10th. Okay, so I'm comparing these. This is my KSP. And this is my Q. And so QSP is greater than KSP. So I have sufficient quantity of ions. Therefore, the precipitate of cerium iodate will form. All right, so that is an example where we find QSP and then how we interpret it.